Hello everyone. In this video lesson you will learn how to divide rational expressions. Okay, so to divide fractions or rational expressions, in this case you end up multiplying by the reciprocal of the second term. So the plan is, first step is you change the problem to multiply instead of division, and then flip the second fraction. And then the second step is make sure every numerator and every denominator have been factored. And then step number 3 is start crossing out or canceling factors that you have in common on numerator and denominator. So for the next two examples, simplify each expression, box your answer, being sure to state any restrictions on the variables. So don't forget, you must restrict anything that has that was ever in the denominator. So that means you get to state the value of x or values of x that we cannot use because that'll make the problem undefined. And also, don't forget, that means there's asymptotes, or there are asymptotes at those values. Okay, so for example number 1, this part here, this one can be factored as x minus 5 times x plus 5, because that's the difference of squares. And for this denominator, there's a GCF of 3. Okay, so I'm going to factor the GCF of 3 and then leave the x here, and then 12 divided by 3, that's 4. So then this is the numerator and this is the denominator. Now for this one here, I'm going to flip it. Okay, so which means I'm going to reciprocate those two. But also I can factor, for example, this one out. Multiples of 9 that add up to 20 are 4 and 5. So then this one factors as x plus 4 times x plus 5. And then this is factors of negative 10 that when you add them, add to a negative 3, that's 2 and 5. So then this is x2 and then x5. So let's see, now we need a negative 3 when we add them, so that means the 5 should be minus and the 2 should be plus. Okay, so you multiply 2 times negative 5, that gives you negative 10, and when you add 2 and negative 5, that gives you negative 3. Okay, so now I'm going to flip those two. So I am going to keep this one like this. So then this is the first expression. So x minus 5 times x plus 5 over 3 times x plus 4. So again, this is the first rational expression. Okay, so then what I'm going to do here is I'm going to flip this one here. So then multiply, instead of division you're going to multiply. So then you write x plus 4 times x plus 5. Okay, so that's the denominator, and now the numerator is going to go down here, so that's this one here. Then x plus 2 times x minus 5. Before I start canceling, this was in the denominator, so that means that x cannot be equal to negative 4, and also x cannot be equal to negative 5 for this one. Okay, and then for this one here, x cannot be equal to negative 4. Again, but notice we have two of them, so that means you only have to set it once, but it's fine if you do it twice. And then for this one here, x cannot be equal to negative 2. Okay, that's for that one. And for this one here, x cannot be equal to positive 5. So then here come the restrictions. So the answer to this is I'm going to cross out or cancel the ones that I see match. So this one and this one, and then this one and that one, and that's all we can cross out, right? So then what we have left is, okay, so this will be equal to, notice that we have x plus 5 and x plus 5. So I'm just going to write that down as x plus 5. We have two of them. So square over, and then we have a 3 in the denominator, and then we have the x plus 2 left. So now here come the restrictions. X cannot be equal to negative 4. X cannot be equal to, we have positive negative 5 and positive 5. So plus or minus 5, and then last, x cannot be equal to this negative 2. Okay, so there are the restrictions on this rational problem. Okay, for the second example, second and last example, there's nothing here that I can do yet. Okay, but there's a GCF here. So I am going to factor out the GCF in the denominator. So then this will be x squared, and this becomes 2x minus 3. And then let's see what else we can do. There's nothing else we can do so far. So then what I'm going to do is I'm going to reciprocate this one here. So, and then I'm going to change this to multiplication. But before I do this, let's see, I'll just do it over here. So then we have 14x cubed over x squared times 2x minus 3. Change to multiplication, and let's reciprocate this one. So notice that this is a difference of squares, because 4 is a perfect square and 9 is a perfect square. So then this one actually becomes, we have, let's see, so we have x, and then using difference of squares, 2x minus 3 times 2x plus 3. Denominator, we have 21x. Okay, but then this 14, 7 goes into 14 2 times, and 21, and 7 goes into 21 3 times. And then let's see what else. So notice we have this x and that x, we can cross it out. And then this square is going to cancel that cube, so this gives you just x to the first instead. So then from here, you can also cross out 2x minus 3. So in the end, what we have left is we have this 2, and this is just x, right? Because this is a square, this is the cube, so there's x to the first left. So we have 2x in the numerator along with 2x plus 3. Over, this will be just 3, the number 3. Okay? But now here comes the trick. You got to set the restrictions. So let's see. We can't have x equal to. Notice if we set x minus 3 equal to 0, that means you add 3 and then divide by 2. So we can't have x equal to positive 3 halves. But also this one, this will be negative. So plus or minus negative 3 halves, plus or minus 3 halves. So that's one restriction. The other comes from having an x in the denominator, right? We have them here. So that means we can't have x equal to 0 because that will make this undefined. Okay, so this is the answer along with restrictions to that second example. I'll see you guys in class. Thank you for watching. Bye-bye.